Hi and welcome to another Type with me. In this video I'm gonna talk about all about types and how to look into these types and go with it to manage inferable types and avoid to use too much typing within your Typescript project, because you don't need to do these typings all over the place, and a lot of beginner applications with Typescript will do that. So these are just some remarks on how to avoid too much clutter in your code with inferable types. So also here I'm gonna use Dino just for the easy part, right? So for example, we have something like x and we just have it as a number. X is a number, and then we do something like 12. Then you will see that yeah, x is really a number, but it's not necessary because we know that it's a number because it's been equalized to that. So we can just remove it, and then again, still the project Typescript knows that it's a number, right? So explicit type annotation is redundant here, so avoid that. When you just have something that you put equal to words a number, then yeah, Typescript just knows that. It's the same with, for example, string. You'll see that now he knows that it's a string, right? Only when you just want to have something like this, string, then you just say that the only value that can be an x is that string, right? You're just gonna narrow down the type, and then it makes sense to do so. Alright, so imagine we have something like this, right? When we go over here, you will see that this is the type annotation, but also here we really don't need this. So when we remove that and then just look into it, you'll see that we have just the same information right there. So also there, avoid to do so and just let Typescript do its job under the hood. So what's true for this is also true for arrays, right? So when we look at this example, we have just a square function, and then we have something like this, which returns just an array. You don't need to explicitly do something like this, because number, and then we have well, you don't need that, right? Typescript knows that already. When you want to know it as a developer, you just go over it and it will tell you that it's returning numbers. And also here, when we have something like that, you will know that it's explicitly a number because yeah, the program just knows. So you don't need to do something like this. So also try to avoid that. It makes it yeah, harder to read over time because you have more types declared there. It's more clutter that's in there. Again, you can very easily go over this, and then you see that that square returns an array of. So when you do something like this, square, then you really see what it is, and then you can just go over it and use it like that, right? So when we go back to our example of a person, right, it is maybe a very good thing to just go there and yeah, just make an interface for a person. And then when you want to refactor a person, right, and you say, yeah, well, when don't need to be a string, but it needs to be a date. You can very easily change that, right? And your program knows that. So that's again a very good thing. So then here you say date, and here also you say date. And then of course we get some complaints. Everybody gets some complaints when the type person is being used, and we can change our program for that. So it's very great for refactoring and for getting errors out of the way, right? So imagine that we have this type of code, right? Well, then you definitely need to avoid this. And I'm going to explain why. It's not a good thing to have const ID number or const name string, right? Because when we want to change this into a string, because yeah, IDs are having also an A, a B, or a C or something into it, well, then now you see that he complains. But when you have a lot of things in your code where you have ID and then explicitly a number, you always need to change your entire code. When we just remove this and also we remove it here, then you will see that we have explicitly the string type there because of block.id. And still a much better code writing is just destructing your object, right? And of course we need to remove ID here. So that's much better style of code, in my opinion. It's much cleaner, compacter, and it's also giving you the type, which in this case is ID string and ID name. And if I just change it here, just on one place, I need to change it, and then ID is a number again. Another thing that you need to know is that when we have something like author equals and then just a string, then also there you don't need to put author string as explicitly there, because also the compiler knows that it's a string, and there yeah, you also need to put it here. But also for default variables on function parameters, you don't need to use a type there because he just knows it. All right. Another great thing that I want to show you is, for example, we have something like const block equals, and then we have ID, which is, and then we have name over block. And then we do something like log block, right? It's okay. But then we want to change this into a string, right? So we do so. Then of course here we get an error, and then you get an error that arguments of type apply is not assigned to parameters of type blog post, types of property ID or incompatible type number is not assigned to type string, right? And then in this case it's better to just use here our type, and then we get here an error that like, okay, block is changed, we need to make a string out of it. Yeah. You immediately know where you made that mistake. So it's very powerful to know when you need to use explicit typing and when you don't need to use it, right? So these are just some remarks that I want to share with you. So things to remember. First thing, avoid write type annotations when TypeScript can infer the same type. And when you have just one place to change the type, and then directly it ripples down into your whole application. So if avoid that, you have that. So avoid type annotations when TypeScript can infer the same type. Secondly, ideally your code has type annotations in function method signatures, but not on local variables in their bodies, right? Third one is consider using explicit annotations for object literals and functions return types, even when they can be inferred. This will help prevent implementation errors from surfacing in user code. I hope you liked this video tutorial and I hope you learned something from it. Please subscribe to my channel to have some more insights into how to work with cool technologies, and also for TypeScript related things, right? So thank you for watching and see you next time.